So good morning students. So in the previous class we have seen about Lagrangian multipliers. So in this class we are going to see a problem in Lagrangian multiplier based on design thinking approach. So Darshan is going to explain about DT concept and the problem in DT approach. So you can.
Good morning everyone. Before I get into the problem, let's make a short intro about design thinking. What is design thinking? Design thinking is a human-centric approach. There are 5 principles in design thinking. They are empathy, define, ideate, and prototype, testing. So these are the 5 principles of design thinking, and we have a problem here that we have a rectangular box here with open surface. We don't know the length, breadth, and height. Now we need to calculate these 3 in the rectangular box. Let me consider this as an empathy. Then what's the define? Let me use the Lagrangian multiplier. I am getting into the problem. Let keeping a length as x and breadth as y and height as z. So the surface area, let it be xy plus 2yz plus 2zx. This is the surface area because we are using here the multiplier, Lagrangian multiplier. Then we have a volume of 32 units. So let me consider the volume as x, y, z is equal to 32. As I told that we are using the define as the Lagrangian multiplier. So let the surface area be f, xy, 2yz and 2zx. And the volume we are having, let it be g, x, y, z, and the constant here comes to the left side, becomes negative, that is xyz minus 32. Now the f is equal to f plus lambda g, that is our surface area plus lambda times of our volume. So the surface area is xyz, 2y, xyz, 2yz plus 2zx. Sorry, here is xy. Now we are going to do the partial derivation. The f we have here is xyz, xy plus 2yz plus 2zx plus lambda times of xyz minus 32. Let's do the partial derivation of x. So dou f by dou x, we get the answer y plus 2z plus lambda yz. The constants become 0 here. Dou f by dou y is equal to x plus 2z plus lambda xz. Then similarly dou f by dou z is equal to 2y plus 2x plus lambda xy. Now we are considering the partial derivation. Dou f by dou x is equal to 0. Then y plus 2z plus lambda yz is equal to 0. I am just considering this one lambda to the right side. So y plus 2z is equal to minus lambda yz. We just need the value lambda. So minus lambda is equal to y plus 2z by yz. Let it be the equation number 1. Now we are considering the second equation as dou f by dou y is equal to 0. So now the dou f by dou y is equal to 0. That is x plus 2z plus lambda xz is equal to 0. Then x plus 2z is equal to minus lambda xz. Now we need the equation minus lambda. So minus lambda is equal to x plus 2z by xz. Now we are having the equation number 1 and 2. Let me equalize in the equation number 1 and 2. On equalizing the equation 1 is equal to 2. Y plus 2z y is equal to x plus 2z by xz. Here, in the denominator, we have a common value z. Let me cancel the z. So, on cross multiplying that, xy plus 2xz is equal to xy plus 2yz. Here, I am having the xy as in, so I am cancelling it. Remaining 2xz plus 2yz. On cancelling 2 and z, we get the value x is equal to y. Here I get the value 1, x is equal to y. Now, similarly, on substituting the y, we get y is equal to 2z. Now we have x is equal to y and y is equal to 2z. So we are substituting the equation, that is xyz is equal to 32. That is 2z into 2z into z. 2z cube is equal to 32. Sorry, 4z cube is equal to 32. Cancelling, we get z is equal to 2. Let me substituting this 2 is into y is equal to 2z. The answer is y is equal to 4. Similarly, x is equal to y, so x is also 4. So the length, breadth and height is 4, 4, 2. Thank you.